Okay, let's get started. Today we're going to continue in College Algebra for Teens with section 2.6 with a final example on the greatest integer function. Okay, there is a problem with the printed notes for this section that were available for this class, and they did not type the symbol for the greatest integer function correctly. So where you have those little boxes, it should look like this. Here's how the greatest integer function works. It takes any number that you put in as x and it rounds it down to the integer that is less than or equal to the number that you put in. Okay, so let's fill in the blanks and then we'll work on a problem and see how this works. The greatest integer function, f of x equals, it should look like this, pairs every real number x that you put in with the greatest integer. The blank should be less than or equal to x. So fill in those blanks on your worksheet with less than or equal to x. All right, so let's actually work an example of this and see how it works. All right, so I've gone ahead and listed these out and I will explain what's going on here. Let's see if I can get this up a little bit higher. Okay, so when we put the number 0 in as the x, and we take the greatest integer, an integer, remember, is a number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth, like the counting positive numbers, 0 and -1, -2, -3, and so on. So the integer less than or equal to 0 is 0. Pick a number like a fraction, 1/2. What integer is the greatest integer that's less than that? So pick a number less, but the largest number. That would be 0. 2/3, 0. Okay, try putting in the number 1. When you take the integer that's less than or equal to 1, it's 1. Any number between 1 and 2, right in here, 1.7, 1.2, round them down to the closest integer, that would be 1. And if you put in 2, the greatest integer less than 2 is 2. The greatest integer value less than 2.5 is 2, and etc. Then I did some negative numbers on the next table, and remember that you can always pause this video and copy things down if I'm going too quickly. That's the way to handle it, or replay it. If you take -1/2 and you plug it in here, what integer is just less than or equal to -1/2? The largest one, that would be -1. -2/3, again, -1. Put a -1 in, -1 is less than or equal to that. -1.5, the integer just below that would be -2, and so forth, okay? So now that we've worked a few of these, let's do a graph to see how this looks on a graph. Okay, I'm going to set this to the side and try to find my empty graph paper that I have prepared for you. Yes, here it is. And I'm going to graph those points. And you'll see how this looks. Okay, I'm going to start with 0, 0. And then I have 1/2, 0. And 2/3, 0. And you can see that everything in this interval goes up to there. But when we get to 1 on the graph, at 1, the greatest integer less than or equal to that is 1. So it doesn't equal that. So we go all the way up to there. We start at 0, go all the way up with a solid line, but we make an open circle around 1 because at the point 1, y will be 1. The greatest integer will be 1. Okay? And anything between the 1.2 and 1.7, they round down to the integer 1. So if we pick an x value like 1.5, the greatest integer less than that would be 1. So the y is 1. Remember that we put the x's in and we get the y's out. And that will go to there. Because at 2, when I take the greatest integer less than or equal to 2, I get 2, and that should be a line straight above it. If it doesn't look like that, I'm really sorry. And everything here rounds down. So this is a piecewise or a step function. It's also called the step function. Okay, let's pick a number here, -1/2. What is the greatest integer less than 1/2? It would be -1. So from here, we're going to be going, all these are -1 up to here. At -1, it's also 1. Greatest integer less than -1 is -1. Okay, and then we jump down. You can see the pattern now that we're doing across the graph. That needs to line up with a 2. I hope it looks that way to you. And then I think you see the pattern. We put a dot, dot, dot to indicate that this continues in both directions, okay? Good. Now, let's look at those fill in the blanks. And the wording on the fill in the blank is not always the best, so this is one of their not the best ones. Let me zoom down a little closer, and the thing came untaped. Okay. Okay. First of all, what is the domain? What x values are you allowed to put into this function? Anything will work. So we go from negative infinity to infinity. The range, that's the output, in this case the y. The output is an integer because it always rounds it to an integer. So it would be y where y is an integer, or you could write the set of integers 0, 1, 2, 3, positive, dot, 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 and negative, counting, dot, 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 okay? And then this should say, though it doesn't quite have the right symbol, and I just dropped my first attempt at picking up a pencil, when f of x is the greatest integer of x, so make that have the greatest integer function. So it should be a square bracket with a double line on each side. It is constant, and it is also continuous. I should have underlined that instead of scratching it out. We've been talking about continuous, so I think they should have said continuous. It is continuous on the intervals, and let's look at the graph here and see how it is continuous. Let's fill that out by looking at the graph instead. That will make a little bit more sense. Where is this thing constant? Constant means it has no slope. The slope is constant, right? Okay. Where is it constant? Where is it continuous? It's the same. Okay, this little piece is constant and it's continuous. It starts at x equals 1 and it goes up to where x equals 2, but it doesn't equal that. So I have a square bracket on the 1 and an open bracket on the 2. This piece begins where x is 2 and it goes up to where x is 3, but it doesn't equal that. It has an open circle there. Let's find a better color for this. This little piece begins at 0 for the x value, and the x values go up to 1, but not including 1. This piece is from negative 1 to 0, negative 2 to negative 1, and so forth. So that is the region where the graph is constant. It has no slope. It has a constant slope of 0, actually. And it's also continuous. There aren't any holes on that little interval, right? So that's what they wanted listed here, and I'll show you this again. So I've listed those intervals and put dot, dot, dot on both ends. It's necessary to put it on both ends because it continues in both directions. And finally, it is discontinuous at all the integers. And the domain of it, which we talked about up here, the domain is from negative infinity to infinity. That's kind of a little bit weird, but okay. All right, let's move to the next example on our lecture handouts. Let me find that. This is example 3. And example 3 says, let me not show you the whole answer first. Example 3, it says that we have a function f of x where we're going to take the greatest integer, we make a square bracket and double side the vertical, 1/3 of the x minus 2. That's how we calculate it. For any x, we put it in, we take a third, we subtract 2, and then we take the greatest integer less than or equal to that value, okay? So what's actually sort of interesting here is where does it switch? Where are these breaking points? Let's look back at the graph we had before. Where does it jump? Where does it go from negative 2 to negative 1 to 0? When do the y's change? Okay. This is equal to y. So what we're really doing here is, let me find my notes, make sure I do this the way I want to. Let's start by saying, where is 1/3 x minus 2 going to be negative 3? Okay, and that's going to tell us on the graph where the y is negative 3, right? where the y is negative 3. Let's figure out what x makes this equal. And these are going to be the breakpoints, and it'll simplify things for us. So 1/3 x is equal to, I add 2 on both sides, negative 1, multiply by 3, negative 3. Okay, so at negative 3, when will the y be negative 2? In other words, where do we jump up? Okay, so if we were looking back to this graph, y was negative 3 down here. When do we jump up to the next piece where y is negative 2? Then when do we jump up? I'm trying to see the pattern for how often we move up. Okay, all right. And now we are going to solve this by adding 2 on both sides. That gives a 0. Multiply by 3, we still get a 0. So it's going to break at 0. It's going to jump up to the next interval. And let's do one more of those to make sure it looks like it's going to jump up every 3, we're going to jump up. So whereas this went across just 1 unit and then it jumped up, went 1 more unit, jumped up, 1 more unit, jumped up. This is going to go, it looks like 3 units before it jumps up. So let's see, when is 1/3 of x minus 2 equal to, we did negative 3, negative 2. The next y would be negative 1 on the greatest integer function. So we get 1/3 of x is equal to, we add 2 on both sides, we get 1, multiply by 3. Oh, we're right. So it looks like it's jumping up every 3 units, it's jumping up. Okay. So we could probably go directly to graphing that. Let's see if I have a graph grid ready to go. This would probably work. Then I'm going to actually do this with plotting some more points too. But so it sounds like when x is negative 3, there's negative 3 for the y. Looking back here, I let y be negative 3, right there. And it turns out that x is negative 3 also. So that gives me a point at negative 3, negative 3. So I'm going to put that point on my graph, negative 3, negative 3. Okay. And then the next point was I let y be negative 2. This is my y, right? Y is negative 2. And when y is negative 2, x turns out to be 0. Okay, so I got these points from my substitution. So 0, negative 2, 0, negative 2. Okay, so if this behaves the way the other one did, the integer function will go all the way over to here and then have an open circle there and jump up. And we predict it's going to go 3 more units. But let's get this next point. Here we let y be negative 1. And the x worked out to be 3. So let's put that on the graph. 1, 2, 3, negative 1 right here. Sure enough, it's going over 3 units and taking a jump. It's going to go over 3 units, taking a jump. Okay, you can see how this graph is going to work. We'll put dot, dot, dot because we're getting tired. And we can just dot, dot, dot it down here too because we've shown how the pattern is going. Okay, now I have also filled out a little bit on a table that I'd like to show you. And the nice thing is with your calculator, you don't have to worry about this. You can just plug some numbers in. Let me let you look at this. So I put a negative 3 in, and I calculated it, and I got a negative 3, which rounded down to the greatest integer, negative 3. So here's what I got before I did the greatest integer, then I calculated down to the integer. So I put negative 2.4 because that's nicely divisible by 3, and I got negative 2.8, which rounds down to the integer, negative 3. So this continues as I tried more examples with my calculator up until negative 1. Well, actually, it didn't switch until I got to 0. At 0, when I put 0 in there, I get a negative 2, which rounds down to negative 2. So everywhere from x at negative 3 up to 0, the y value is negative 3. So let's look back at this. Everywhere from x at -3 up to x equals 0, the y value stays at -3. That's exactly what we had earlier. Okay? And you can go ahead plotting points on this or look back by stopping the lecture at the ones I did. I didn't do them anymore. I actually had done some before. I'll put this up here in case you want to look at it. I did those, and I didn't show the middle step here. I just showed what you got out as the y. And there's my graph on smaller graph paper of the same function. Okay. The next example is exactly like example number 4 on page 254 in your textbook. And so I'm going to actually ask you to read that example this time for sake of time. And we can take a question on that in class if you would like to when we come back. And the final thing we need to do in this section, this last example, we have some fill in the blank here. It says, recall that the function is a relation where every domain value is paired with one and only one range value. Okay? To be a function for each x, you have one and only one y, right? Domain and range. And then we have one more example. This is x to the x equals y to the second. So this is actually not a function of x, but a function of y. So when we graph this by plotting the points, which they've done for us, I get a parabola that opens to the right. And that's because instead of x squared, when it's x squared, they open up or down. When it's y squared, they open to the right or to the left. Okay, so we are asked to tell what the domain is. And as you can see, the x values begin at 0 and they go on to infinity. And then we ask the range, and as you can see, the y values are going up slowly but constantly. So the range will be from -infinity to infinity. Okay, now you have done everything that you need in order to complete your homework assignment for 2.5, which we did today during class, and 2.6, which we did today in class, and just finished up with this last bit on the video recording. So when I see you next, we will move forward from these. If you have any questions, please email me, and I will be prepared to do those at the beginning of class next week. Take care. Talk to you later.